Good day to all of you. Today we shall discuss direct memory access, that is DMA. So first, what is DMA? DMA means direct memory access is the approach which is used for huge block of data transfer between main memory and external devices. And what is DMA controller? DMA controller is the special controller unit or interfacing circuit that does direct data transfer here. Figure shows processor, memory which are connected through system bus, and the IO devices, keyboard, printer are connected over the same system bus to processor and memory. Whenever a keyboard is pressed to input the data word by word, it is transferred to main memory involving processor. Then in case of printer also, from main memory word by word over system bus, the data is transferred to printer involving processor. So in an interaction between IO devices, keyboard and printer and main memory, the CPU is involved, processor is involved. It has to poll the status of these IO devices and see whether they are ready, yes or no. When keyboard is ready with the data, then processor reads the data from keyboard and puts into main memory. And when printer is ready for printing, then processor transfers the data from main memory to printer for being printed. So this procedure is for one word transfer between main memory and IO devices, keyboard and printer. And in the figure we can observe DMA controller. There are two DMA controllers. One DMA controller is connected to high-speed network through network interface. Another DMA controller called disk DMA controller is connected to two disks. So these two disks are connected to system bus through DMA controller. Whenever a high-speed data is coming over the network, through network interface, it enters and be stored in DMA controller buffer. Now if it is to be transferred to main memory, DMA controller requests the permission from processor. Once the permission is granted, the DMA controller gains the control over the system bus. It becomes the master. Now whole of data from DMA controller is transferred to main memory and be stored in main memory. This is called as memory write operation. When memory read operation, a block of data from main memory over system bus is transferred to DMA controller buffer. From DMA controller buffer through network interface at a very high speed, it is transferred over network. So this kind of arrangement is required for synchronization between slower memory and faster network device. And this synchronization is achieved by the use of DMA controller. When DMA controller completes the operation, it hands over the control to processor back. That is, operating system switches the control from the execution of main process to data transfer routine when DMA controller is doing data transfer operation. When DMA controller completes that operation and processor is informed, then operating system switches back the control from data transfer routine to main process. Here huge block of data transfer takes place without the intervention of processor. So even if the processor is not involved, but processor only initiates the operation. For that, it sends to the concerned DMA controller the data regarding the starting address in the main memory where the data is to be read or written into, then how many words of data are to be transferred, and the direction of transfer, that is whether it is read or write operation. Read operation means the data is transferred from main memory to external devices. Write operation means the data is transferred from external devices to main memory. After giving this much information, processor relinquishes the control over the system bus to DMA controller, and DMA controller becomes the master, and it does the complete transfer of huge block of data. So after completion, it informs the processor and gives back the control over the system bus to processor, and processor continues its work. This is how DMA controller works. And that is all about what is DMA and what does DMA controller do. Then what is the need of direct memory access? There are totally three modes of data transfer between main memory and external devices. First one is polling, second one is using interrupts, the third one is DMA transfer. In polling, the processor has to continuously check, that is poll, the status of whether they are ready or no. Only when IO devices are ready, then the processor has to do the data transfer operation. So for this, processor is engaged in checking the status information. In the second one, in the scheme of interrupts, the processor has to wait for an interrupt signal from the IO devices. So in both the cases, the processor time is wasted. So to avoid this, in DMA controller, huge block of data transfer takes place without intervention of processor. But processor initiates the operation by giving needed information to DMA controller and regarding how many words of data are to be transferred, that is word count, and the starting address in the main memory, and the direction of transfer, whether it is read or write operation. And then it gives complete control over system bus to DMA controller. The DMA controller transfers whole of huge block of data between main memory and external devices. When it completes, it informs processor that the data transfer is completed. Then the processor takes back the control over system bus and it resumes its operation. Without processor involvement, huge block of data transfer is done between main memory and external devices. I hope you understood the need of direct memory access. Next, what are the different registers present in DMA transfer of data? So DMA controller we define as a special controller unit or interface unit that is used to transfer huge block of data between main memory and external devices. For this, in every DMA controller interface unit, there are three kinds of registers. The first register is called as status bar control register. Another one is starting address register. The third one is word count register. This is what is shown in the figure here. The starting address register, there the processor will have sent to DMA controller from which memory location in the main memory the data is to be transferred. So that address is stored here. And word count, how many words of data are to be transferred. Next, in status bar control register, 4 bits they have shown. That is, one is done bit. This bit indicates when DMA controller completes the operation. It sets a done bit as 1. Then it is an indication to the processor that corresponding DMA controller has completed the data transfer operation. Next bit, read bar write bar r/write bar bit. This indicates the direction of operation. If it is 1, that it is read operation, that is the data from main memory it is being sent to external device. If it is 0, then it is write operation, the data from external device it is stored in main memory or written into main memory. I argue when this bit is set to 1, when DMA controller completes the operation, this bit is set to 1, indicating that DMA controller is requesting the processor that its work is over so that processor can take back the control over system bus. That bit is also called as IE bit, interrupt enable bit. So this bit is set to 1, that is whatever the interrupt request is sent from DMA control to processor, that is enabled. Okay. So these are used for communication between processor and DMA controller. With this, synchronization needed for data transfer is achieved. So these are the registers present in every DMA controller interface unit and respective functions. We already know that direct memory access, that is DMA, it is the mode of data transfer. It is one of the method of data transfer between main memory and external devices, where huge block of data is transferred without the intervention of processor, but processor only will have initiated the transfer and given the permission to DMA controller, and the DMA controller is the interface unit or the special controller unit that transfers whole block of data, and after completion it will inform the processor through interrupt request bit. Then processor will have come to know that the data transfer operation is over from DMA controller and it takes back the control over system bus. But which are the different modes of DMA transfer? In that, the first one is burst mode. So these different modes are there. When we study, we'll come to know which is slower and which is fastest that is available in DMA transfer kind of data transfer. So the first one, if you consider burst mode. In this mode, whole block of data that is transferred at a single stretch. Once the CPU gives the control to DMA, that is a DMA controller unit, then whatever block of data is mentioned, that is transfer between main memory and external devices. This is a fastest mode of data transfer since at once huge amount of data is being transferred. Okay. The second mode is cycle stealing mode. Every DMA controller unit needs time for keeping the data ready. Till then, CPU will be using the system bus. When once the DMA controller is ready, it informs the processor that it is ready for data transfer. Then processor gives the control over the system bus to DMA controller. So DMA controller then does huge block of data transfer. Next, for next block, till making ready, the controller is given back to processor. Processor will resume its operation. When processor is doing its operation, DMA controller will make ready the next block of data. So again, when it is ready, it informs the processor, and again from processor the control is given back to DMA controller, and this is the procedure followed in cycle stealing mode. This mode of transfer in DMA, it is little bit slower when compared to burst mode. Then third mode is interleaving mode. Here the processor is executing some program. It will be using the system bus, but whenever it is not using that system bus, then only it gives the control over system bus to DMA controller for huge block of data transfer, not at the request of DMA controller. So hence from the request of DMA controller in this mode, CPU will not be blocked at all like in previous two modes. This is the slowest mode among all the three modes here. Hence in a given time, only less amount of data can be transferred when compared to other two modes. That completes the whole discussion about DMA, that is direct memory access. I hope you understood. Thank you.